This video lesson is designed to introduce you to chemistry and the periodic table. You will need for this video lesson colored pencils or crayons in 5 colors, your yellow learning targets packet, your Unit 1 notes packet, the periodic table that was given to you in class, and a pencil or pen to take notes. If you need to gather any of these materials, feel free to pause the video at this time and go gather the things that you need. In your yellow learning targets packet, notice that your learning target, number 1, also falls underneath a standard, 1. We refer to this learning target using the periodic table to determine information about an element as being target 1.1. Under standard 1, target number 1. Today, as part of this lesson, you will define period and family with respect to the periodic table. Use the periodic table to look up the atomic name, atomic symbol, atomic number of an element. Learn to use the periodic table to determine whether an element is a metal, nonmetal, or metalloid. And lastly, learn to identify the location of the main group metals, transition metals, alkaline earth metals, halogens, and noble gases on the periodic table. Notice that I have circled these things on the yellow learning targets packet so that you know what things you are expected to know at this point in the course. Unit 1 will address nuclear chemistry, which is basically the structure of the atom inside its nucleus and some of the ramifications of that structure. Before we can start to talk about atoms in the nucleus, we need to get a handle on chemistry and the periodic table. Chemistry is the study of matter and the changes it undergoes. Matter has mass and occupies space and includes a number of things, anything you can see and touch, as well as a number of things you cannot see. The primary focus of chemistry is to describe how the various atoms interact with one another to undergo chemical and physical changes. Our universe is composed of relatively few of these atoms, and the most convenient list of these is a periodic table. You were given a periodic table in class that is a colored copy and has boxes that look very much like this. The boxes contain a lot of information, but at this point in time, you need to be able to identify very few things. You need to be able to identify the atomic number, which is the large number in blue in the upper left of each box. You need to be able to find every element's name, its atomic symbol, and you'll notice that if you scan the periodic table, the atomic symbols consist of 1 or 2 letters, and the first letter is always capitalized if there's more than 1 letter. And lastly, the atomic weight, which is the little red number in the upper corner. The atomic weight is measured in units of AMUs, or atomic mass units. At this point, you don't really need to know what an atomic mass unit is, only to understand that atoms are so tiny it's not practical to measure their mass in terms of grams and pounds and kilograms and ounces and other types of units of mass that you're familiar with. The other useful piece of information you can get from the periodic table is the physical state of an element at room temperature, which is about 25 degrees. If the elemental symbol is written in black, the element tends to be a solid at room temperature. If the symbol is blue, the element is a liquid at room temperature. There are only 2 of these. The blue elements on the periodic table include mercury, which is number 80, and bromine, which is number 85. The elements whose symbols are in red are elements that are gases at room temperature, and the ones that don't seem to be any of these colors or are unshaded are synthetic elements that people have created. You don't need to remember these colors. If you look down at the bottom of your periodic table, you'll see that note number 1 does tell you what the different colors represent. You will also notice, looking at the bottom of your periodic table, that in the lower left-hand corner is a key that will help you remember what the various numbers stand for. The periodic table has kind of a funny shape, and the shape of the periodic table is significant. We need to have some words to describe both the rows and the columns on a periodic table. A row on the periodic table is given the name period. That's where the periodic table gets its name. A family or a group is the term that we use to describe a column on the periodic table. Next, we're going to identify some regions of the periodic table that have some special group names. I don't want you to write or color on the big periodic table you were given in class, but you'll notice that in your notes you have a smaller periodic table that you're going to begin to label and color. You have already learned that a column on the periodic table is called a group or a family. There are 4 families that have names that are commonly used by chemists. The first column is referred to as the alkali metals. Although hydrogen is in this first column, it is not considered to be an alkali metal because it is a gas at room temperature. As you get deeper into your understanding of chemistry, you will understand why hydrogen was placed in the first column of the periodic table, even though it is a gas. The elements in the second column of the periodic table are called the alkaline earth metals. The elements in the first 2 columns of the periodic table are all very reactive and are not found as elements in nature. These 2 families of reactive metals occur naturally only bonded to other elements to form compounds. Next, we will jump to the other side of the periodic table to the set of elements in fluorine's column. These elements are called the halogens and include fluorine, chlorine, bromine, iodine, and astatine. The last column on the periodic table with a commonly used family name is the noble gases. The noble gases are located at the far right column of the periodic table. With a few rare exceptions, these elements do not form compounds. Some of the remaining families do have names but are not commonly used, so you do not need to know. Next, you are going to color code the little periodic table in your notes. Elements on the periodic table are classified into one of 5 categories. These categories include main group metals, nonmetals, metalloids, transition metals, and intertransition metals. Choose 5 colors and make a key similar to the one shown above. I will be using highlighters for mine because they look nice on screen, but you can choose any color of crayon or colored pencil you would like, or if you have 5 colors of highlighters, that will work too. You may want to pause this video while you make your key. First, you will color the elements that are considered to be main group metals. These include the alkali metals. Remember not to color code hydrogen because it is a gas, not a metal. The alkaline earth metals, and one element from the other side of the periodic table, aluminum. Aluminum is easy to remember because you are familiar with aluminum foil, which is clearly metallic in nature. Next, you will locate the nonmetals on the opposite side of the periodic table. Also go back and pick up hydrogen from the first column. This section is a little tricky to color, so go slowly and choose your elements carefully to match the ones that are colored green on your screen. The next set of elements has properties of both metals and nonmetals. They are called the metalloids and create a border for the nonmetals. Notice the dark blue staircase on your big periodic table. And I've drawn in this staircase on the little periodic table in your notes. With the exception of aluminum, the metals that touch this staircase are considered to be metalloids. Metalloids have the properties of both metals and nonmetals and are used to make things like semiconductors that allow us to use devices like cell phones and computers, and a lot of our other digital technology is dependent upon these metalloids. The next group of elements are metals, just like the first 2 columns, but have some special traits and get a special name designation. The transition metals are located in the shorter columns of the periodic table and in a little triangle right here that extends over underneath the metalloids. Most of the metals you are familiar with, such as silver, gold, copper, zinc, iron, and others, are transition metals and are found in the middle region of the periodic table. Lastly, we have the bottom two rows of elements, which are called inner transition metals, despite the fact that they are located outside of the main table. These elements belong in the empty spaces, right here, and have been removed from the periodic table simply to make the periodic table a more convenient size. There is one last term that you need to be familiar with when using the periodic table. Chemists use the term representative elements to refer to the elements in the tall columns of the periodic table. These are also referred to as the main group elements. And that's where we get the term main group metals. The main group metals are all the metals here in yellow that are part of the main group elements on the periodic table. This concludes your tour of the periodic table and types of elements.